Hello everyone, and welcome to another video about mechanical vibrations. In the previous video lectures, I have discussed with you how to derive equations of motion and the mathematical techniques that we require for solving them. So in the next block, we can really solve these equations of motion. And I will do this basically in two steps. First, I will look at what we will call the free vibrations of a system. So these are vibrations without that there are external forces acting on the system. And then we will look at what we will call forced vibrations. And these are vibrations of a system due to these external forces. So for introducing you to these free vibrations, we will start by just a single degree of freedom system. And I have brought with me today an experiment to show you the basics of free vibrations. Let me adjust the camera a bit such that you can see the experiment. It is really spectacular. So we have this card here. It's mounted on a rail. It can move left to right and is attached with two springs to the fixed world. And the idea of free vibrations is that we are going to look at what happens to this system if it is disturbed from its equilibrium configuration, so that its current configuration, for whatever reason. All right, so imagine that for whatever reason the system is disturbed like this, and then we release it from rest and see what happens. It vibrates. All right, so what I just demonstrated was an initial displacement. We can also look at what happens if the system is given an initial velocity. It looks like this. It also vibrates. And what we see in both these cases is that the system vibrates in a particular frequency. This is what we will call the natural frequency of the system. And of course, it's interesting to find out what this natural frequency is and what does it depend on. So that will be our first task. What is the natural frequency of a system? And then, using these techniques from ordinary differential equations, I will explain to you how can we describe mathematically the response of the system. So the coordinate of this card as a function of time. Let me demonstrate it again. You see vibrations, oscillations. I think from that point of view it already makes sense that in this response it will be something with sines and cosines. Maybe you can imagine that x as a function of time will be some sine-cosine combination. This is the case if the system is undamped. As soon as we include a little bit of damping, if we wait long enough, the system will come back to its equilibrium state. Then this amplitude will decay over time. How can we describe that? And what happens if we keep on increasing the damping? So this is an important question that we will address in the next sessions. So for these free vibrations, I will need two video lectures. The first one is on the general solution. What is the natural frequency and what is the solution in general? And in the second video lecture, I will explain to you what are these special cases. How does the response depends on the amount of damping? So two video lectures, and after that, you are able to describe what you just saw in this experiment. I hope you like these lectures. Good luck, and I'll see you in the next one.